Welcome to today's webinar brought to you by Datavail. I'm Stephen Fegg, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Cloud Cost Optimization Strategies, Tips, and Best Practices. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speaker for today, I'm excited that we have Michael Agarwal, Director and Global Practice Leader for Cloud Databases at Datavail. Michael, welcome to the broadcast.
Thank you, Stephen. Pleasure being here. I'll give a short introduction about my background. I have 25 years in IT. I have done software development, database administration, technical project management, and I've been in cloud architect role for 10 plus years. And because of a lot of projects that I have done, I have what I'm going to share today is the knowledge around cloud optimization and all the projects in last 10 years that I can share with you today. A little bit before I go into the cost optimization, let me give you a small background about the company I work for. Datavail is a global company with 1,200 employees over US, Canada, Colombia, and India. We are Oracle Platinum Partner, AWS Advanced Consulting Partner, and with Azure, we have Solution Partner and Advanced Specializations. We also build a couple of intellectual property around database monitoring and the service, ITIL-based service management. Datavail has a strong AWS credentials. We are in many programs, and we have over the time earned many service delivery partner designations as well as AWS competencies. With AWS, there are four superpowers that Datavail has. We are into databases and analytics, definitely that our a strong area for database management, building data warehouses, data lakes. Also, we have business units around .NET, app modernization, and Oracle workloads on-prem or migrating them to cloud. Today, I'm going to cover how the AWS cost structure is broken down. If you happen to be on Azure or OCI, a lot of things are very similar. I would say 90% things are still similar. How other cloud platforms has a cost structure. I'm also going to review what tools are available from AWS for looking at your bill, analyzing your bill, getting alerts. And then I'm going to go over cost optimization tips. Some are easy and some are not so easy, and depending on what the mechanism we pick for cost optimization. And then I'm going to relate how cost optimization relate to if you happen to have Cloud Center of Excellence in your organization, how that relate to it. So the AWS cost structure is if a lot of customers have EC2 and RDS, and that has to come with lift and shift. So they had a VM on-prem, they went to AWS, they moved to EC2. And it's not always easy to develop a new application. Sometimes there's no business benefit. And even if there's a business benefit, sometimes the cost is high and not always you want to containerize it or make it serverless. So a lot of things still running on EC2 RDS. It's very basic, simple cost structure is the hourly rate that you pay for CPU and memory. and then and the disk you attach is extra charges. It also has ingress and egress charges. So anything coming to the AWS region is all free of cost. Anything going out of AWS may or may not have a cost. So we have to look into that. There is a small charge within the availability zone. So AWS region may have multiple availability zones. And if you configuring your systems for high availability disaster recovery, there's one cent per gig charge, for example, between the availability zones. And then, of course, it's a charge if you go from AWS region to another region, or if you have a public facing website, or if you have a hybrid cloud, the data out of AWS back to your data center may have some additional cost. So something to be aware of. For the most part, AWS is structured for pay for what you use. What that means is you don't have any upfront cost. It's pay as you go. There's no um, contracts for long-term engagement either. So with one exception, which is the reserved instances and savings plans, where you do have some commitment. But for the most part, there's no commitments, there's no upfront, and you pay for what you use. So if you have very small EC2s, you might have $15 a month charge, for example. But if you have very high EC2 GPUs for AI and whatnot, you may have a higher charge. The one important thing to know as you move away from EC2 and RDS, which is a lot more almost all the time running compute, to more container and serverless, the pricing changes differently. And each AWS service has a pricing model. So the best thing to do is, and I can't remember all of them either, but the best thing to do is, just type AWS, for example, if you're using EMR or Glue, just, EMR space pricing, and then you will see the pricing model, and same for Glue and DynamoDB and whatnot. Um, what serverless, for example, has is, or managed services, for example, has is a usage based model, not necessarily a compute based. What that means is EC2 RDS, you have compute running all the time and you're paying hourly. But a lot of serverless services like Lambda, DynamoDB is invocation based, or in case of DynamoDB, you're doing a read and write, and you may have an application which doesn't do read and write in the night time and only do during the daytime, right? So you're only paying charges on the daytime for queries, and so that's a pricing model based on. Now, each managed service have different features, and in some cases, if you're using that feature, you might pay additional fees. For example, in case of DynamoDB, there's a global table concept where it's replicating the data between different AWS regions. So you may have global customers, and the application is serving globally, but you need to have replicate the data between, let's say, US region and a APAC region or European Union region, and that you have to pay extra for that, for example.
Hey, Michael, we just had a question come in, and I think now might be a good opportunity to address it. Can you just dive in a little further on the pricing model? The question and comment was that it kind of seems like it's nitpicking, to pay for every feature you might want.
I think it may sound like that, but let me give an analogy. So, for example, if you're buying a car, not everybody need a sunroof, for example, or defrost mirror, for example. If you live in the south, you may not need a defrost mirror, right? So the idea here is to be more fair, to compare to charge something high for everybody. So if you look at DynamoDB, for example, the example I have, it's pretty low charge, 1.25, $1.25 per million request. And this the request unit is how many kilobyte of data you read and write. So it's pretty simple, but not everybody need global tables. So why AWS should charge all other customers for global tables. So I would say it's a wrong way to look at it. Nitpicking, I think the right way to look at it is AWS is trying to make it more fair and only charge customers who need those features, similar to somebody buying a car and and only paying for things you need. So the very first thing about AWS cost optimization is actually knowing what's going on. So unless you know what's going on, it's hard to pinpoint where your cost is, how to optimize it. So I always advise customers to set up multiple billing alerts. So if you're expecting your monthly bill to be $1,000 a month, set up a $1,000 and 1,100 and 1,200 multiple alerts just in case you want to track that way. So you have minimum, maximum, for example. In a large enterprise, and even medium size, I would say have somebody assigned who own watching the cost. So they don't necessarily have to log in all the time, but they need to have all the alerts going. They need to go know on a daily basis how is looking, monthly bill is looking, how AWS is projecting your cost to be monthly bill. And then you start analyzing trends, where your money is going. Is it EC2, RDS? Are you calling a lot of Lambda? Do you have elastic IPs? Is it ingress, egress cost? Not ingress, but anything coming into AWS is free, but any egress cost to, is it public facing? So all that cost breakdown is there, and analyzing it to see what is going on. Also, as you are provisioning AWS services, often customers will have some kind of tagging. So if you have a HR department, payroll department, marketing, whatnot, you might, and you creating servers and applications for that department, you might have a cost tagging. So not only analyzing trends, but also looking at, okay, how the systems I have for accounts payable or accounts receivable, how they are looking cost wise month by month. And that tagging kind of help you analyze that cost. AWS has provided a lot of tools as well, in addition to the cost explorer and billing. AWS has a trusted advisor, which will kind of actually more than cost. It will also look at security, reliability, performance, whatnot. So it's an automated tool. It looks at, it has a built-in automation, reasoning, whatnot. And when you run trusted advisor, it will kind of advise you what things you can do. The one thing I will say, trusted advisor, is it doesn't know a lot about your business, or sometimes what the peak season might be, things like that. So something to be aware of is like you can't blindly trust a trusted advisor, but in the sense what it provides you, you can definitely, is a starting point for you in some cases to kind of look to find out where to look for. If you have a lot of um, um, desktops on Amazon workspaces, there's a cost optimizer tool for that. If you have a lot of production, non-production, and you want to turn on and off, we used to do actually without the tool. We write a Lambda and turn off and off non-production environment, for example. But now AWS has a tool called Instance Scheduler, where you will schedule turning EC2s on and off, for example. It also has cost anomaly detection. So if things are out of the bound for what is expected, it will detect and alert you. Also, it has a compute optimizer. So if you have a lot of RDS EC2, the compute optimizer will kind of give you some indications on what are the areas whether you have over provisioned EC2s and whatnot. It will kind of advise you and guide you with your cost optimization journey.
Michael, another question. Would you mind sharing just a little bit more about the new cost optimization hub?
Oh, look like somebody paying attention to reInvent. So few days back at reInvent, there's an announcement that there's a cost optimization hub. So that's the AWS way to help customer cut down the cost. Um, and there's a lot of white paper around it. There are a lot of trusted advisors is there. So definitely AWS wants to help customer understand the cost and optimize it. So now this new cost optimization hub is pretty important in the sense, you find out what are the opportunities for cost optimization, but you don't resolve that in a day. Some are long term. As we go through the presentation, you will see some are, you can probably do in a weeks or maybe month, but some are long term, and tracking those and reporting on what are your cost optimization initiatives and how you're performing month by month, week by week on those initiatives. It's a way is AWS is providing a tool to kind of help you with managing that. So next section, what I'm going to cover is some easy wins. And the reason I want to start with easy wins is, like, I think everybody can relate. You can do in weeks or months and kind of provide pretty fast turnaround to the organization you work for in terms of cost savings. The very first I want to go over is EC2 RDS pricing model. So EC2 RDS has many different types of pricing model. I'm going to cover the spot instances later on, so I'm not going to cover on this slide. But EC2 RDS, they both have on demand, but also they have reserved instances and savings plans. So on demand is good. You want to get started. You don't know how things going to work out. Ready to necessarily have any savings plan, reserved instances, and it's a good way to start, because you can start anytime, you can finish anytime, you can decommission your resources anytime, not a problem. But if you are on AWS and things are working good for you, and let's say you have 100 EC2s and 100 RDS, for example, and you're going to keep that for next 1, 2, 3 years, why not sign up for reserved instances, which give you up to 72% cost savings? Savings plan is very similar to reserved instances. There are some minor differences. Savings plan now is a little bit preferred way, has less restrictions. Reserved instances have more restrictions. So the savings plan is relatively new also. So going to reserved instances, or if you already on reserved instances and moving to savings plan, is a good way to kind of cut down your compute cost and your AWS bill. The other area that is important is the storage. Now, a lot of times when you're doing backup, or you may have a document storage for your applications, whatnot, the S3 buckets can get bigger and bigger in size, and if you're not paying attention, if you don't have a lifecycle policies, it can become very costly. So a couple of things to know about S3 storage. One, it has different types of storage. So making sure you pick the right one. Most of the customer by default pick standard, even though they may not need standard. And then the all the objects stay on standard, then you're paying a standard price, compared to, let's say, if you don't need that often, or it's more for just in case I need it, move it to more cheaper storage like Glacier. Also, there are things in between, like infrequent access. Infrequent access is like, I'm not ready for Glacier yet, but I'm not going to be needing every day either. So something I may need, once a week, once a month. So it's infrequent access. So it's a cheaper storage compared to standard, for example. If you don't need a high redundancy, you can go for reduced redundancy, and that has a cheaper option. So finding the right storage for the right objects, files, is the starting point. After that, you look at how long you want to keep those objects. Is it a week, month, 7 years? Because sometimes there's a tax filing and tax documents has to be stored for 7 years. Sometimes compliance even higher for 10 years. Sometimes a healthcare record. And sometimes you don't need after 1 week. It just depends. And then if you have the right bucket for the right object type, you can set up a lifecycle policy to say, and it happens automatic. You define a lifecycle policy, say, after 1 month, move these type of objects from this bucket from standard to glacier, and it happens behind the scene, and nobody forget about it, and things are taken care of. If you don't need it in standard, let's say after 2 months, you can say after 2 months, purge it. Or even in glacier, you can say keep it in glacier for 6 months and then purge it, delete it. You don't need anymore. So purging, of course, better than archiving to glacier, but sometimes you have to keep it longer time. So that's where glacier comes in. But my recommendation is purge it. If you don't need it, just purge it. And also with a lot of times snapshot, EC2 snapshots, whatnot, go to storage. So there's no reason to keep a lot of snapshots there. So just keeping latest snapshots is all you need, and then purging the ones you don't need. And this is my favorite area, and often not looked at. So what happens is in a large enterprise, you may have developers, you may have vendors, contractors, whatnot, and it's not like they're trying to increase your bill. They may not have that thing in their mind all the time, and so they may make a mistake, um, and then they may not turn it off, for example. So there are a couple of things to be aware of. So I talked about billing alerts. So of course, if somebody created 100 EC2s all of a sudden using infrastructure as a core like Terraform or CloudFormation, and the billing alerts will start to tell you that something got spin up and you're looking at higher monthly charge. But in addition to that, if you're doing everything through the infrastructure as a code, which is a highly recommended way to do it compared to logging to the AWS console and doing from there directly. So if you're using Terraform, CDK, CloudFormation, there are many other ways to do it. You generally have a code repository like GitHub, GitLab, AWS code commit, for example. So you have different code repositories, and as you're deploying it, somebody senior might review it, and that might be way to avoid mistakes. The other way is if you are using multi-account architecture within the AWS control tower, AWS organization, there's a concept of AWS service control policies where you can kind of define which services are available in which regions, and that way, that's another way to control it. Um, the the more important thing is, so I'll give you one example. There was a developer who wanted to do performance testing and had the right reason to do it for a Redshift cluster, but instead of creating a small cluster, he created a 128 node Redshift cluster. And not just that, he wanted to do over the multiple days. He got busy, forgot to turn it off, and the bill was very high. So how you avoid that? So this is where the right permissions. There's a concept of IAM permission boundaries, peer reviews, and just education also. That if you don't need something for experiment, use infrastructure as a code. And when you destroy your infrastructure as a code stack, all the resources get deleted, and then you can create again using the same infrastructure as a code when you're ready to experiment again. So just awareness in your developers, contractors kind of can save you a lot of mistakes and accidental jump in the AWS bill, a monthly bill. Also, the other compute cost is the storage. So I covered CPU memory earlier on, um, but AWS has multiple options, including your traditional hard drive to general purpose solid state drive and provision IO solid state drive. The pricing for the regular hard drive, general purpose SSD is getting very similar. So yes, there's a cost saving for going for a um, general hard drive. But the biggest difference is going from general purpose to provision IOPS. So provision IOPS should be used very carefully. Use it where you only need it. General purpose GP3 has a lot better performance than GP2. So it used to be that general purpose 2 may not work, so you go to provision IOPS, but GP3 start to be a lot better performance. So likely GP3 will work. In non-production, you likely not need provision IOPS unless you're doing a performance testing. Maybe your performance environment is same as production. But even production, GP3 might work. So provision IOPS is, you looking for high throughput and guaranteed IOPS. So it's not like general purpose will not perform. It's just not guaranteed to perform high. Compared to provision IOPS, is performing high, but it's also guaranteed to perform high. So what I mean there is 90% of the systems, in my experience, are perfectly fine with general purpose. Maybe 10% of the systems where you do have a high throughput need, you might need provision IOPS. So picking the right storage type and size also, of course. If you don't need 5 terabyte, just go with 500 gig or 1 terabyte, whatever you need, and some additional space, of course, for growth. But don't go overboard with large size hard drives. There's another aspect of cost savings, which is licensing. So often customers has SQL Server, Windows, Oracle, many other third-party products, which are for the most part licensed per virtual core. So it's better to kind of optimize that. So how you optimize that, right? So the hardware on AWS is kind of newer. So for example, and on-prem you might have 24 core, but you go to AWS, you might be okay with 16 cores because relatively newer processor, whatnot. So be aware of that, and then the benefit there is not only you paying less AWS cost, but also your licensing footprint is smaller because it's licensed by virtual cores. I also advise to go for the new instance family. What that means is AWS has many generations of compute EC2s. For example, M5, R5. But going for newer means newer architecture, newer hardware architecture, new optimizations, newer processor, faster. So it's always advised to go latest compared to a previous generation instance types like M5, R5, for example. So those are the things you can do for licensing, and should be very easy and faster to do it to kind of figure that out. A lot of times, customer has, let's say, Oracle's enterprise license or SQL Server Enterprise Edition, and the question I ask is, do you really need it? And if you don't, and we look at, so Enterprise Edition is needed because there are some enterprise features. So what we do is we look at what we're using for, try to figure out, is it really a good reason to keep using Enterprise Edition, or you actually go with standard. And in some cases, like SQL Server also has, the Express, SQL Server Express, for example, or SQL Server Developer Edition for non-production, things like that. So something to be aware of, and why pay for Enterprise Edition when you don't need it? That's the kind of essence of this discussion. Also, as customers are thinking about going to cloud, there is a and if they have a lot of SQL Server windows and Oracle, it's a good opportunity to look at licensing assessment. So what that is, the licensing assessment not only look at how your licensing will go to AWS, but also what your AWS cost will be for like to like, for example, or maybe if your CPU memory not utilized that much, maybe you can have smaller footprint on AWS. But the idea here is the OLA assessment is to kind of have a good picture of what you have today and what licensing and cost is going to look like on AWS before you decide to migrate to AWS. And in some cases, AWS provide funding also to kind of help with that OLA assessment.
Hey, Michael, another quick question, if I may interject. We had someone ask, can you please share what is OLA assessment and what deliverables are included?
Yeah, sure. So the OLA assessment often start with understanding what you have in terms of licensing questions. So we look at your Microsoft Enterprise Agreement, Oracle license agreement, and how many CPUs and are being used for those licenses on-prem today. We run a tool. There are many tools out there. For Oracle, for example, we might run a script, or for SQL Server Windows, we might run AWS Migration Evaluator, for example. But the idea is to collect what you have first, and then we look at, okay, if we do like to like, or in some cases a smaller EC2 instance because your utilization is low on CPU, for example. So we run that tool for 2-3 weeks or even months sometimes to kind of get a good idea about what utilization look like on-prem. And then we run the calculator, AWS calculator with different options, a dedicated host versus shared tenancy. For databases, for SQL Server, we might do SQL Server on EC2 versus SQL Server on RDS. Same for Oracle, we might do. We look at the how many licenses you need, or are you sufficient with licensing you have, and will that license will carry over. If the license does not carry over for whatever reason, or you're short on, let's say you need 50 but you only have 40 licenses, we give you idea about what that additional 10 license will look like. Or you actually can go with AWS also have license included model, where you paying a higher compute cost per hour cost, but you're not necessarily buying upfront license, for example. So we provide you all that in a very nice report, and kind of work with your team to kind of go over our findings. And it's a pretty good assessment, and kind of help you visualize and understand your AWS and licensing cost. So now I'm going a little bit more. It could be time taking, complex. It could be easy depending on the situation, but a little bit more complex situations. In some cases, it may be architecture thing that or architecture pattern that might impact your cost optimization. So as you know, on AWS, you have, for example, elastic IPs, right? And if they are not attached, why pay for it, right? For example, things like that. And let's say somebody creating AWS resources through console, and then when they don't need it, they deleted EC2 RDS or any other main resource, but they forgot to delete other resources. So there are always resources like storage and security groups and whatnot, and route tables and VPC subnet, whatnot, right? And then some of these might cost you money, and so that's the benefit of using infrastructure as a code. You can destroy and create anytime using the same code, and when you destroy it destroy all the related resources and let you know that everything got destroyed, so you don't leave anything behind. And it's very good for experimentation, non-development environments. Also, infrastructure as a code kind of give you idea what is being deployed without looking at even sometimes AWS resources. So it's a good way to kind of find out what is being created. Also, AWS has a tool called Resource Manager, which can kind of help you visualize what resources you're using, and now it actually covers multi-account also. So you can also use Resource Manager to get an idea what is being used and what is not being used. This is another area where it takes time. The reason I say that it takes time is a CPU or memory pressure doesn't come all the time. So just because you have 50% CPU utilization and 50% memory utilization doesn't mean you can cut down your cores right away, because you have to support peak time, right? And you provision CPU and memory for the peak performance, or whenever your traffic is high or workload is high, right? So and if you cut it down, maybe the performance is so bad that cutting down from, let's say, 8 to 4 core wasn't a good idea. You have to go back to 8 core, right? So the idea here is to look at not just the average utilization, but what's the peak performance look like, and is it okay to have a okay performance during the peak hours. So in some cases, if you have 95% utilization on CPU memory, it's okay, because it just there's a pepper, that's what you allocated. It's working fine. It's just taking longer, and there's no reason to increase the CPU memory just because 95%, because the system is performing uh, as expected from the business side. In the technical side, you might worry that it's 95%, but it's working, right? So that's where I think the analyzing what is important to business, what is the peak performance look like, what's the average utilization look like, and then deciding the right, and then moving to the different instance type. And the other thing to know is also um, there are different types of instance types. So general purpose will give you a CPU memory ratio, average. Memory optimized will give you more memory for per core, for example. CPU will have less memory, more cores, for example. So depending on workload, you might need more memory. Databases often need more memory. And if you have very batch processing, a lot of compute, you might need more cores. So picking the right instance type, there are roughly 10 different instance types on AWS. So picking the right instance type category will be helpful, and right sizing will be very helpful there. The other aspect is auto scaling. So a lot of times, if you have monolithic applications, or applications or databases which don't horizontally scale, the only option you have really is just keep increasing CPU memory, and you can get to a point where it's not only very costly, but you're stuck in terms of performance. So that's where a horizontal auto scaling can help. What horizontal auto scaling will do is it will scale up and down both based on the traffic. So now, since it is a pay as you use model, when it scales down, you pay for less resources, and when it scales up, you pay for more. And it's okay to scale up when you have more traffic. So for that, I don't think it's always a very easy setup, because sometimes your application and workload has to be able to support the horizontal scaling. Your database has to support horizontal scaling. So that's the reason I put into not so easy win, because you gotta, if you are monolithic, you have to kind of refactor a lot of components to allow that horizontal scaling. So horizontal scaling will help you with not just performance, but it will also help you with cost optimization.
Hey, Michael, can spot instances be used for containers?
Yeah, sure. So I will cover that question in a bit, but yeah, that's a good question. So I covered earlier on-demand instances and reserved instances, right? Um, AWS also have spot instances, and it's heavily discounted. And the way the model, the pricing, the business model behind the scene is that AWS is have new hardware racks all the time, and they rather use it than just be standing there. And that's where that spot instances come from, right? So AWS set a price, per hour, how much they that customer must pay. It's still discounted heavily, but how much you must pay to use spot instances. As long as you agree to that uh, per hour rate, you can use it. And if at the end of the hour, if your pricing doesn't match, AWS will take away those resources. So spot instance is not, if you, let's say we have a website which has to be up and running all the time, may not be a good example there. But it may be a good example for something which can wait, number one. So if you are running analytics, batch processing, even machine learning, if a machine learning model may take a day or two to finish, if you're okay with that, maybe spot instances may be a way to go. So it's not for, as I mentioned, it's not for all workloads, but specific workloads where you're okay with delay, you're okay with, and also your workload and application should be written in a way where it can carry on where it left off. So what that means is, let's say a workload takes 10 hours to complete, and then after 2 hours, your resources are taken away. The next time you get spot instances, you don't want to start all over. You want to start where you left off. So you still be left with 8 hours only. So you have to kind of write your application state in a way that you can carry on without losing the work. So a couple of things you have to do to use spot instances. But it's a good backend engines, machine learning, batch processes. All that is a really good example of using spot instances. And can we use containers for spot instances? The answer is yes. As you are developing microservices, whether the microservices are for backend processing or machine learning um, or ETL, could be any of those. So as this uh, microservices scale, you may have one container or hundreds of containers running. And as long as you are able to meet the pricing model, and as long as your workload is able to keep the state and start where it left off, yeah, you can use containers also, and then just keep state somewhere where outside the container where you're not keeping the state. And this one, using AWS managed services could be easy or not so easy, and I kind of give you some examples. So AWS has, of course, a long running, or in some cases consistently running compute like EC2 RDS, and as I mentioned, a lot of customers have that. But AWS also thought about, okay, how I help customers with uh, cutting down the compute. It helps the environment also, right? But also help a customer and cost optimization. So how about I create services which could be shared? You use it for 1 microsecond, 1 millisecond, all the way to hours if you need it, and then you only use it for you pay for what you need. So they come up with a lot of services, including API gateway, Lambda, DynamoDB, Kinesis, whatnot. And these all you can configure in a way that auto scaling is there, and some things auto scale too. So DynamoDB, for example, you can set up a min and maximum, but you can also set up for automated scaling also, for example. And the idea here is, um, it's a usage based model, and you're not paying for, it's not dedicated to you, it's a shared services, secure, and customers can invoke and use it, and pay for usage based. So a lot of times, when you don't have a very high uh, throughput, you might benefit from using managed services. And but if you have a very, instead of millions, you getting into billions of requests, then it can be pricey also. So you got to look at, what kind of work out better for you. In terms of adopting managed services, it's a lot easier when you developing something new, of course. But if you have application already running on traditional EC2s and APIs are hosted on EC2, for example, things like that, then you have to kind of do refactoring, and it can take uh, a lot of work to refactor that, depending on the complexity and the magnitude of the application. I gave some examples here for Lambda, for example. If you it's invocation based, how many times you invoke and how long it runs, right? So there's a pricing model for that. As you can see, it's pretty cheap if you're if you're invoking million times Lambda in a month. Doesn't run very long. It might be cheaper to do Lambda compared to hosting something similar on EC2, for example. That's another topic. Sometimes we get overcautious about HADR. Do you really need HADR on non-production? Likely not. Um, in some cases, the development environment is so critical because of deadlines. Maybe you do need there, but but that's rare. Mostly you only need in production, for example. So just making sure what HADR model is good for you. Do you want to go for ability zone failure or region failure? Region failure, most people don't need it, but in some cases, the security compliance might have a need to go outside the region. The region already have multiple ability zones, and each ability zone is multiple different data centers far from each other, so you really don't have to go outside region. And same for non-production environments. Do you really need it? But at the end of the day, the business need to know what is the cost of HADR for the RTO and RPO requirements. So business might say initially, oh, I want zero time for everything. But when they see the cost for a um, 0 second RTO RPO, they might say, okay, we're willing to make a compromise and say non-production we don't need it, for production we need it. So business need to know both. They need to know what is the RTO RPO and how much it's going to cost them, so they can make a right decision. Similarly, sometimes you need development environment only 8 to 5 or 7 to 6, and the instance scheduler or a automation like Terraform, code pipeline, you can create and destroy development environments, test environments, whatnot. So the more orchestration you have around that to create and destroy resources that you need or don't need, the better you're going to be able to save money. It's never a good idea to just keep running. So that's one thing that to be aware of. It's not like on-prem where you keep it running. Is you want to be very careful about what keep running and what does not. Most cases you want to keep production environment running. Very rarely you turn it off. But if production environment happens to be a batch or background processing which only run 2-3 hours, you might actually have orchestration there too to spin up production and destroy it when you don't need it. So definitely something to be aware of, and the tooling is there to help you. Often customers have very large footprint of Oracle, SQL Server. They both have licensing. Um, MySQL and Postgres has come a long way. Additionally, AWS made additional effort to opt to create managed services like RDS or things like Aurora, which has the underlying engineering is so good that it performs very well and gives you reliability, performance both. So it has the PostgreSQL, MySQL both has become a enterprise database. It's open source, but it's for enterprise high throughput databases. So there's no reason to actually have Oracle SQL Server for the most part. It may be a lot of work to move from there, or maybe less work. So Oracle SQL Server both could be changed to migrated to MySQL, PostgreSQL. AWS does provide schema conversion tools, some automation, DMS for data migration service. So there are tooling out there to kind of make it easy. So I still put it not so easy win because it's not very rarely you can do in a month. It takes a little bit time, and the more complex, the more database objects you have, the longer it takes. This is another area which can take time. If you have monolithic applications in Java, .NET, Node.js, doesn't matter. Um, very tightly coupled. The only way to scale is to scale all services together. It hurt with performance because you can't do horizontal scaling. It also hurt with cost. Microservices help with scaling individual services. You scale only the service you need, not all of them. But also it helps with performance with horizontal scaling, and then also the cost because you only scale the microservice you need, not all of them. But it takes time to refactor that, and generally it's not a quick win. It takes time to understand and rewrite those components. So I covered a lot of cost optimization strategies, tips, how to do that. But a lot of organizations also have Cloud Center of Excellence. The idea around Cloud Center of Excellence is to be more enabler, not necessarily you have to have approval for everything, but more of a how you put a standard around everybody in the organization to move fast. That's the main purpose of Cloud Center of Excellence. Getting everybody on the same page, put some blueprint, govern a framework in the place, and governments any governance is clear and people can move fast, right? Your business transformation is aligned with technology transformation, so you're not necessarily just doing it just because of better technology, but there are business outcomes assigned to that. The Cloud Center of Excellence may also have standardization around what taggings you should use, what regions you're allowed to create AWS resources, what the namings might be, what different VPC accounts out there. So all that guidance kind of help the entire organization move fast because they can understand it, and then it's okay. I understand as I'm developing a app for innovation, but I know the framework and I can move fast. So that's the idea about it. Also, AWS has tons of architecture patterns. Use that. There's no reason to reinvent the wheel. There are architecture patterns for high scale throughput, event driven architecture. Use that reference as in your Cloud Center of Excellence. Um, you want to enable your teams to do well architecture reviews, or whether you do internally or you go to companies like Datavail, for example, or any other company, AWS partner company you might know, and perform well architecture reviews. One of the reasons I'm showing Cloud Center of Excellence is the cloud maturity model, and the cost optimization should be part of your Cloud Center of Excellence. The maturity model will help you understand how mature you are in your organization, whether it's things as simple as I need to have logging monitoring, but also what I do with those logs. How do I have any auto remediation? Is the cost allocated properly? All those aspects are very important in your Cloud Center of Excellence. With that, I think I'm at the end of my webinar. If you want to schedule a meeting with me, just let us know. Um, uh, and there's actually a drawing to win the beer, or I think it also has a fruit or wine, I think, selection also for a year. So just let us know if you want to meet, have any questions around that, and I will be glad to meet you and talk about your use case. With that, I think I'm about to conclude my session. Steve, any questions? Anything else come up?
Absolutely. First, Michael, the most important question: are DBTA moderators allowed to get the free beer?
Yeah, I wish I get free beer too, but yeah, you're not. Sorry.
Understood. On a more serious note, yes. Here's a great question that came in, and I did want to save it for the end here. The question is, Michael, how does automation play a role in achieving cost efficiency? And what specific tasks or processes can be automated to optimize cloud costs? I know this is somewhat of a broad, all-encompassing question, but any thoughts or input there?
I think we always want to start with where you spending more money, right? So working it backward, right? So once you understand your cloud bill and you look at, okay, my logs are just keep accumulating, or you know, folks are creating unnecessary EC2s and not destroying it, right? So finding out what is actually costing the money is a start, and then you work it backward how you fix it, right? Automation. So if folks are taking backups and S3 buckets are getting full, things like that, that's where you put up lifecycle policies that automation help. If you have folks creating EC2s in a development environment, there's no governance and education around it. Maybe you ask them, do you really need them, or maybe put some automation to say, okay, you don't need it from 5 p.m. to 7 a.m. So I'm going to have an instance scheduler or some kind of automation to turn off. So I think it depends. There are literally thousands of automation possible, including CloudWatch event rules and whatnot. And knowing where the cost is, starting there, and then working it backward to put the right automation in place is the way to go.
Understood. Thanks, Michael. I think we've got time for one more question, and it's coming from me. If there's one thing you'd really like our attendees today to walk away keeping in mind, what would that be?
I think as a global citizen, we all have responsibility to take care of our planet Earth. And what is a better way to save the money, but also support our planet Earth, right? There's no better way, right? So I think anybody in cloud, whether using AWS, Azure, OCI, GCP, doesn't matter. And a lot of things I covered today, it applies to, I would say 90% of that applies to, I may have used AWS specific terminology, but the concepts kind of apply to other clouds also. So anybody using cloud today, even on-prem, we all have a social responsibility to optimize cost. Don't make it secondary. Don't make it a primary objective. And we should all be empowered to educate our co-workers, our leaders, why cost optimization is so important. And with that comes with looking at your cloud bill and understanding what's going on and understanding the right architecture patterns and the ways you can cost. And so start there and make a difference.
Absolutely. I like that. It's all about not only optimizing costs, but obviously minimizing waste, which is, yeah, absolutely. Well, I would like to give a huge thank you to our speaker today for coming on board with us and sharing his insights and expertise. Once again, everyone, Michael Agarwal, Director and Global Practice Leader for Cloud Databases at Datavail. So if you in attendance would like to review this presentation or send it to a colleague, you can use the exact same URL that you used to attend today's live event. It will be archived. It'll probably be up tomorrow afternoon, and you will receive a notification from us. So you know that it's up to watch the recording. And again, as I mentioned earlier, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced later today. Very exciting. And we will let you know if you are the lucky viewer. Thank you, everyone, for joining us, and we hope to see you again soon.